chapter 1 of the physics. It's unit and measurement, and these are the sources from this the topics has been taken, so you can have a look. So we'll be starting up with the measurement. So what is measurement? Measurement of any physical quantity involves comparison with a certain basic, arbitrarily chosen, internationally accepted reference standard called unit, right? Now physical quantities. Those quantities which can be defined and measured are called physical quantities, right? So the quantities which can be measured and defined, right? Examples are length, force, temperature, etc. A physical quantity can have a numerical magnitude and a unit. The laws of physics can be described in terms of physical quantities. So as we know, in physics we have a magnitude and even we have a units in physics, right? Physical quantities are classified into following categories. Fundamental quantities. These are the basic or base quantities which are independent of each other. Example: mass, temperature, length, time, current, amount of substance, luminous intensity, and many more. Next is the derived quantities. These quantities are derived with the help of fundamental quantities. So the derived quantities are dependent on fundamental quantities, but fundamental quantities are independent. So taking the example, momentum, area, volume, force, etc. So volume is length into breadth into height. So taking it in the form of length, length into length into length, that is the volume is equal to the length cube, right? Here volume is derived, which is derived from the fundamental quantity length. So in this, the fundamental quantity is the length. Next one is the supplementary quantities. These are also two physical quantities which are neither fundamental nor derived. These quantities are supplementary quantities. Example: plane angles and solid angles. Next is the scalar and vector quantities. On the basis of direction and their magnitude, physical quantities can be derived into following parts. What is magnitudes? It's the size of the quantity of the value, right? Scalar quantity, a physical quantity which has only magnitude but no direction, is called scalar. In physical quantity, it has no direction. The examples are distance, energy, power, time, speed, volume, density, pressure, work, charge, electric current, temperature, specific heat, frequency, mass, etc. Next is the vector quantity. A physical quantity which has magnitude as well as direction is called vector quantity. Example: displacement, velocity, torque, position, acceleration, force, weight, momentum, impulse, electric field, magnetic field, current, density, angular velocity, and many more. So next is the measurement of physical quantities. To express the measurement of physical quantities, the following two facts are essential. The first one is the standard unit. It is the unit in which the quantity is measured. Example: meter is the unit of length. The unit should be precise and of convenient size. Numerical value. The numerical value or the magnitude of the quantity, that is the number of times that unit is contained in the given physical quantity. Example: when we say the length of a rod is 20 meters, it means the unit of length is meter and the length of the rod is 20 times the magnitude of the meter. Classification of units. Units are classified into following categories: fundamental or the base unit. The units used for measurement of fundamental or base quantities are called fundamental or base units. There are 7 fundamental units, that is kilogram, Kelvin, meter, second, ampere, mole, and candela. So this is the table. These are 7 fundamental units. Now coming up with the derived unit, the units of all physical quantities can be expressed as combination of the base units. Such units obtained from the fundamental units are called derived units. Example: meter square, meter cube. The process of deriving a derived unit can be understood as follows. Speed. The formula for speed is equal to distance traveled upon time taken. So putting up the units here: unit of speed, unit of distance, that is length, unit of time. So unit of distance is meter and unit of time is the second. So the unit of speed becomes meter per second. right? Next is the supplementary unit. The units used for the supplementary quantities are known as supplementary units. Example, unit of plane angle and the solid angles. Next is the international system of units. The common systems of measuring physical quantities are given below. CGS system, it's centimeter, gram, second. In this system, the units of length, mass and time are centimeter, gram and seconds respectively. And it is also called Gaussian system. Next is the PFS system, foot, pound, second. In this system, the unit of length is taken as foot, the mass pound and the time is taken in second, and it is also known as British system. Next is the MKS system, meter, kilogram, second. In this system, the units of length, mass and time are respectively meter, kilogram and seconds respectively. The very common one is the SI unit, International System of Units. SI was adopted and accepted in the International Conference of Weight and Measures held at Geneva in 1960. On the basis of comprehensive consensus, SI units is extended in modified form of MKS. In SI system, there are 7 base units and 2 supplementary units. So now we'll have a look for the 7 fundamental and the 2 supplementary. The unit of length is meter and the symbol is small m. Mass is kilogram and it's represented by kg. Time, second, it's represented by small s. Electric current, it's ampere, capital A. Temperature, Kelvin, capital K. Amount of substance, mole, and the symbol is MOL in small letters. Luminous intensity is candela, the symbol is CD in small. The 2 supplementary quantity, plane angle, it's radian, RAD, and solid angle is steradian, capital S in R. So this is a very important table, so you can just have a screenshot for this. Next, we'll have some definitions for the fundamental units. First one is the meter. 1 meter is the length of the path traveled by light in vacuum during a time travel of 1 by 299, 792, 458 of a second. Kilogram. On atomic scale, 1 kilogram is the mass of 5.0188 into 10 to the power 25 atoms of C12 isotope. What is second? 1 second is defined as the time interval in which the Celsium 133 atom completes 91926317770 vibrations in an atomic clock. Ampere. 1 ampere is defined as the current which, when maintained in 2 straight infinite length parallel conductor of negligible cross section and placed 1 meter apart in vacuum, would produce a force equal to 2 into 10 to the power minus 7 Newton per meter of length. Kelvin. 1 Kelvin is the fraction of 1 by 273.16 temperature of the triple point of water. Mole. 1 mole is the amount of substance which contains as many elementary entities as there are atoms in 0.012 kg of carbon-12. Next is the candela. 1 candela is the luminous intensity in the given direction of a monochromatic source that emits radiation of frequency 540 into 10 to the power 12 Hertz, and that has a radiant intensity in that direction of 1 by 683 watt per steradian. Next is the definition of supplementary units. Radian. 1 radian is the angle subtended at center of a circle by an arc equal in length of the radius of the circle. Steradian. 1 steradian is the solid angle subtended at the center of a sphere by that area of the surface of the sphere which is equal to the square of radius of sphere. So this is the table for physical quantities and the SI units for the same. For area, it's length into breadth and the SI unit is meter square. Volume, length into breadth into height, and the unit is meter square. As we are taking all these 3 things in meter, so we'll just multiply its meter cube. Density, its mass upon volume, kg per meter cube, right? Speed or velocity, distance or displacement upon time, meter per second. Linear momentum, mass into velocity, kg, meter per second. Acceleration, change in velocity upon time taken, meter per second square. Force, mass into acceleration, and the SI unit is Newton. Impulse, force into time, and the SI unit is Newton second. Pressure, force upon area, it's Newton per meter square. Work, the formula for work is force into distance, and the SI unit is joule. Energy, it's work, and the SI unit is joule. Moment of force, force into distance, Newton meter. Power, work upon time, and the SI unit is watt. Surface tension, it's force upon length, Newton per meter right? Thrust, it's force, SI unit is Newton. Coefficient of elasticity, stress upon strain, Newton per meter square. Moment of inertia, it's mass, radius of gyration square, kg meter square. Angular acceleration, change in angular velocity upon time taken, it's radian per second square. Frequency, it's number of vibration upon seconds. It's number of vibrations or seconds is hertz. Planck's constant, it's energy upon frequency, joule second. Resistance is potential difference upon current, and the SI unit is ohm. Capacitance, the formula is charge upon potential difference, and the SI unit is farad. Specific resistance or resistivity, it's Ra upon L, and the unit is ohm meter. Conductance, it's 1 upon R, means 1 upon radians, it's 1 upon ohm. Electric reflex, it's electric field into area, it's Newton meter per capacitance, right? So this is the table. So I'll just continue the same in the next video. So if you like this video, please like, share and subscribe my channel for more such videos.